Today, we're going to hear about curiosity at work and how curiosity has been the driver that inspires us all to learn and create something to make our lives better. We'll be exploring how one engineer, working with scientists, helped NASA bring things into day-to-day lives that have made our lives so much better, safer, healthier, and more. And in Grounds for Thought, I'll be talking about what it means to bridge the divide between different perspectives and come out alive. Thank you for joining me today. I'm Madeline Blair, and this is Unlocked, a show all about unlocking the resilient leader in you. If you like the show and you like what we do and support us, the free, simple way to do that is to hit the thumbs up or subscribe button. My commitment to you is that I will do everything in my power to make this show better for you every single week. Thank you so much. When this show is aired, it is September 11, the anniversary of the Twin Towers accident, attack in 2001. I remember that day as I was briefing a civilian executive who was an admiral equivalent in the Navy. Her aide broke into our meeting with the news. After checking in with her staff, she signaled that I could continue. I told her that I could not, as I was so moved by the event. She graciously said we would reschedule and said that I must call her when I got home to make sure that I was all right. It's a memory I will never forget. Each year at this time, I renew my sadness for the victims and the appreciation for the men and women who worked to retrieve those in the towers and the Pentagon, and to that executive who treated me with such humanity. Where does the urge to study the sciences come from? When I think back to my growing up, there was so much that piqued my curiosity. I mean, one day I wanted to be a botanist, and one day I wanted to be an artist, and the next time I wanted to be a mathematician. I think, but more than anything, I wanted to be an astronaut. In the end, I chose mathematics, but it could easily have been botany because I've always been interested in growing plants. But it was my math teacher who signaled me out, telling me I had talent in math. And I switched majors right then and there, taking every math course the university taught. I still love math, but I've never lost my curiosity for the other disciplines of science. Sciences were always considered honorable disciplines to study, but I think we may have forgotten what science has done to make our lives better and better. We'll be exploring that and more after a word from our sponsor. Since the 1800s, Smith Island cakes have been a symbol of family, faith, and community. In 2009, the Smith Island Baking Company was created as the custodian of this treasure, shipping hundreds of thousands of cakes made from scratch, packed with care, and delivered to celebrations of all sizes and shapes, far and wide. Today, people just like you celebrate important occasions with a cake. When is your next birthday? Welcome back. I'm Madeline Blair, and you're listening to Unlocked. Today, we're talking about curiosity and science, and my guest today is Jeffrey Yoder. After a distinguished career marked by leadership roles in both engineering and science, Jeffrey Yoder retired from NASA. His tenure included serving as Deputy Associate Administrator for the NASA Science Mission Directorate, where he managed a diverse portfolio of over 100 missions, most notably serving as the program director for the transformative James Webb Space Telescope. Mr. Yoder's contributions touched upon every facet of NASA's ambitious endeavors, from the Constellation and commercial crew programs to flagship observatories like the Hubble and the pioneering Mars rovers. Today, a lifelong champion of curiosity and exploration, Mr. Yoder dedicates his time to sharing his experiences with students, igniting a passion for discovery and encouraging the next generation to relentlessly pursue knowledge. Let me bring Jeff on the screen. Jeff, welcome to Unlocked.
Thank you. It's such a pleasure to be able to share my story and to be part of this Unlocked. I've seen it before, and I think this is tremendous. So thank you.
Thank you. I want to begin by, thinking about the only place to start our conversation. To me, as a curious species, we're inevitable as humans to want to explore even the stars. And frankly, as I have mentioned, I admit a burning desire to know, like what the surface of the planets look like, what it's like to ride a comet, what it's like to watch a star being born. I mean, it's amazing what I have all my life desired. But to do that from our place in the universe takes an enormous amount of energy and resources, an enormous amount of focused expertise to build a rocket, something that's often only used once. What does humanity gain from this incredible effort, besides satisfying a bit of curiosity?
Yeah, curiosity is, I think, innate in our DNA, whether it's for space travel or even deep sea diving and things like that. For me, the curiosity started when I was just a little kid, looking up at the stars, wondering what's up there. But now let me jump forward to where my passion really is within NASA. And NASA, for every mission that they develop, really requires new innovation, new technologies, and one mission builds off of another. But as part of that, NASA is also chartered to what from these new technologies, um, how can they be transformed into the things that help the civilization, help
Mm.
us here on Earth. And I'm reminded of a story. Well, I shouldn't say of a story, of an experience I had in 1998 when the Mars rover, or the Mars 98 missions had failed. And I was walking through the LAX airport, had my NASA jacket on, and through the Ford food court, there was somebody behind the counter that started hollering at me and using things words that made me uncomfortable. And I thought he was going to jump across and fight me. And his comments were, you, meaning NASA, just wasted all this money. Couldn't have we spent it better on somewhere else? And I thought, oh, our message isn't out there that it's more than just the mission. And then several years later, I was talking to my niece, whose mother had just passed away from cancer. And I was telling her about the research going on in the International Space Station for cancer research, growing cells faster.
Mm.
And she stopped me. She goes, "Oh, wait, what do you mean? We have people living up there?" And I thought, oh, even within my circle, the information is not out there. So, I thought it's important to share some of these innovative activities that are going on within NASA and the technologies and how they really benefit us here on Earth. Lately we drive around our cars, you punch in the GPS number and off
Yeah.
you go. Well, that was generated back on how do we track the satellites years ago.
Yeah.
If I go back to the Apollo era, they needed to figure out how to drill core samples in the lunar surface. Well, you didn't have a big extension cord, so they came up with this battery method. That now, I shouldn't say now, but back then, that was transferred into Black and Decker, and we had the dust busters. So you think back to that, and you mentioned James Webb, and that's James Webb Telescope is really near and dear to my heart as a previous program director. But that had technologies that had to be invented, and one of them is the mirrors on the telescope itself. It's really wide. It's 100 times more capable than Hubble, but it needed to be very, very flat and without any ripples or anything on the telescope on itself. We didn't have the technology to measure to the level that we needed. And as an example, the mirror, just a section of the mirror, if you stretched it across the continental United States, the highest bump could be 1 inch.
Oh
So
my goodness.
yeah, so it's just fascinating. So the engineers, contractors got together and figured a way to make this work. Well, that helped us from a vision standpoint, but that same technology now is used by eye surgeons to really measure your eye prior to starting LASIK surgery. Stuff that we think is common right now. Um, that's fascinating.
When you said that, I said to myself, oh, well, they're really going to have a problem making it smooth. But that wasn't the problem. The problem was making sure that it was smooth by being able to see it. Fascinating.
Exactly. And there's other things on the Webb telescope. So it needed to travel 1 million miles out, and it needed to operate in a very cold environment. And so we're talking minus like 380 degrees. One instrument had to be minus 400, roughly 430, 440 degrees Fahrenheit. Well, that's a technology challenge in itself because it's so close to absolute zero. Our standard margins didn't even accommodate for that. So we had to develop the new techniques on testing to verify that it would work and that it wouldn't deform itself. Just like when you take your binoculars and go in really high zoom in. If you move just a little bit, you lose focus real quick. That's the same way with these technologies. What was developed on James Webb Telescope is now used also in other missions. The same types of technology. There's one other mission that was really near and dear to my heart because any time we can also convert some of this stuff into for human safety on Earth, I'm all for it. There was one mission that was in partnership with the Japanese Space Agency, JAXA, to help us understand early detection of tsunamis and things like that. That mission was launched and went into commission, it verified itself. And about a month later, the major tsunami hit Japan. And at the time, the U.S. ambassador to Japan, Carolyn Kennedy, commented that this mission was credited with saving over 1,000 lives.
Wow.
You think, okay, it's science, but it also was life-saving. There are other missions that took technologies, and we mentioned GPS, used GPS and some other technologies to launch 8 little microsatellites to help us understand hurricane speeds. If we can understand the hurricane speeds faster, one, we're not flying as many planes through the center, and we're reducing risk to life. The other thing about science that I think is really fascinating is when we really want to look in the far distances, we need lightweight instruments, lightweight, detectors and things like that. So somebody, and I'm not going to mention names through this, was looking for a technology and invented a technology called CMOS. It's a CMOS detector for lightweight, for imaging distant planets and things like that. That same technology type now is in your cell phones, in your GoPro cameras, things like that. Things we take for granted. That if that mission weren't there, would we have that? Would somebody have picked it up? In addition to that, when you're looking at distant planets and distant areas, you can have kind of a fuzzy resolution, and you go, oh, okay, I need this better. And so they developed, NASA and its contractors developed this algorithm and technique to really refine the images. That same technology is now used in MRIs. So early detection of any growths or things in your arteries and stuff, little things that ultimately would lead to strokes, potentially lead to strokes and heart attacks, infused into the medical area again. So it's just phenomenal. I think when I asked the standard person on the street, what was NASA known for? Velcro. Well, obviously we use Velcro. NASA didn't develop Velcro. That was developed in the 1940s by an engineer whose pant pockets, they had the flap pockets.
Mhm.
kept lifting up. So he invented Velcro to keep them down. Now
Mhm.
NASA used Velcro tremendously in space station and stuff. So there's just so many technologies. I got new glasses the other day and they said, "Oh, you want scratch resistant on it?" Oh, yes, I do. Where'd that come from? NASA developed the scratch resistant technology for the instruments like on station and others so they wouldn't get all scratched up. That now was transferred to Scotch Foster Grant, through a licensing agreement. So there are literally thousands and thousands of these technologies that have transferred from these inventions.
And Jeff, as you're talking, I'm thinking to myself, well, we could have invented those anyway. But it was the fact that there is a purpose in solving a particular problem. That, yes, we were concerned about making MRI readings better and better, but there was not necessarily the real push that you had from the space program that instigated that research that created that technology. Uh,
No, yeah, and you're exactly right. It was needs driven.
yeah,
And so if you think back to, say, the GoPro cameras, what would have been the need to say, okay, I need final resolution? There could have been another technology, but it was verified. All the R&D was basically done
yeah,
for the space program, for science, to help improve science.
yeah.
It's just one last one is for the International Space Station, the astronauts in zero gravity. How do they train? Well, you aren't going to lift weights when there's no gravity. Not very good. So they thought, well, what if we use these rubber band things? Well, that kind of works, put some resistance. So one of the scientists and engineers developed this thing that's, well, it actually looks like the Bowflex that you can buy commercially now. That's where it came from a need to help exercise at the space station, help
Yeah,
bones, things like that.
yeah.
The benefits are just tremendous.
Yes. Well, as you're talking about all these amazing things, what comes to mind is the very first one, GPS. I just think for for peace between couples that this is an amazing contribution from NASA. Because how many times have you been trying to get somewhere and one person's in the driver's seat and the other person's in the co-pilot seat reading the instructions, and all of that has been eased.
And it's, again, NASA publishes an annual report of the technology transfers. I tried to touch on some samples of just different ones, from deep space to James Webb to human space flight. But there were just thousands and thousands,
Yeah,
and it's just amazing.
yeah.
I ask somebody on the street, can you name 5 technology transfers that NASA has done? And again, Tang comes up in the things I mentioned earlier, and I would question if many people, even within NASA, could name maybe 10 of the actual transfers. We kind of get in this space bubble of thinking everybody understands what's going on, but when you get outside of it, not so much.
Well, as you were talking, I was thinking to myself, Black and Decker? You mean those batteries that are in those things that I can go outside and work in my garden? And I mean, all of that was done because something in space needed to have power where you couldn't have an extension cord.
And you think of the power drills that we use,
Yeah,
all the stuff,
all
starting
that
with
stuff.
Genesis from back there. So,
Yeah,
with the I'm trying to think the technologies and stuff that are, for me, the passion on the technologies really is, how does it help human lives and human lives from a curiosity standpoint and physically? Can it? There's one that years ago in the International Space Station, water is important and recycling water. So they developed this technique to take all kinds of liquids and recycle them to where they're clean. That technology now is used in third world countries to
yeah,
help,
yeah,
where they had contaminated water. And
yeah,
you just think of all of these things that, I question would they be available today?
yeah. No, and again, the there would not have been an immediate commercial need identified because but once the technology was there, then there could see that application. Well, there's another aspect to all this, uh, because when you're I know that these projects that you talked about with NASA must have been enormous projects. Uh, Large teams of people spanning many years. I mean, what was I'm trying to think. One of them was 25 years from start to finish, and I'm sure others were like that. Talk a little bit about what it takes to really manage that kind of team versus a simple small team, maybe a half a dozen people uh, in a few months.
Yeah, no, that's a good question. And I'm just going to use the James Webb Telescope as an example.
Okay.
When it was first identified as this is what we need to do by the National Academy of Sciences, that was in 2000. We launched in what, later than 2020, so 2 decades. So the challenges, it's not like, it's a short period. You have to deal with burnout potentially. You have to deal with funding. Is the funding really going to be there for 2 decades?
Mm,
Are the stakeholders, are they going to be engaged? So you have to have this constant support. I've spent a lot of time on Capitol Hill and in the White House, the executive office of the president, the EEOP, talking to the advisors and things, trying to make sure that we had the support that we needed. Or if there were issues, to be right up front, honest, and say, hey, here's an issue we have, and here's what we're doing about it, to really keep the buy-in. Training, you know, somebody could, win the lottery and decide that's more important and leave a hole if they leave. So do we have any people in what we call single point failure mode, but where if they leave, there's a really big gap. So do you have the cross training going on?
gosh, I wasn't thinking when you said training. I wasn't thinking about the cross training. But you're absolutely right. People do leave, whether they won the lottery or not. They could choose to go another place.
Well, and unfortunately, on the Webb telescope, there have been deaths, and so for
Yes.
various reasons, while you don't want to think about that, you actually have to think about those things if they leave, and then the documentation has to be good, clear documentation that you can hand off from decade to decade almost to keep this thing keep it going.
Oh, God, documentation. We had, I had another guest on. Her name is Renee Wynn, and she talked about the fact that there were actually special librarians that managed all that documentation.
And one of the other things is at the end of a mission, whether it's a large mission or small, we were required to write a lessons learned. And then how does that get transferred into new missions?
Yeah.
So communication is just communication within the team and communication um, verbally as well as written communication.
Mhm.
And then morale. How do you keep the morale up? There were certain missions that we were on, and James Webb was one of them where it looked like it was headed for cancellation. Well, how do you keep the team engaged? And I think about this today when you're looking at the potential budget cuts in the Science Mission Directorate. But I'm thinking back to what the morale must be like in there right now. And I personally wish I were back in NASA, because one of the things that I really tried to do was to work on employee morale, because if the employees are happy or feel like you have their back,
They perform.
they perform exactly.
Yep. No
It's
question. No question. Hmm. There's another aspect of this. Uh, you, as I recall, you're an engineer. You're not a scientist per se. So, and NASA is filled with lots of science people. Talk about what it means to work on a science project as an engineer.
very, very good question. And I think it's one that sometimes is misunderstood a little bit in the answer. So I years ago started out in the prior to NASA working some DoD missions, some commercial missions, and it starts off with something called needs, goals, and objectives. What's the need for this? What is the goal, and then what's the objective? So the need, you could translate this into there's a need for astronauts to be able to communicate when they're doing spacewalks with the International Space Station or Space Shuttle. Okay, then the goal would be we're going to have radios, and the objectives to have communication system that can do monitor your health within certain ranges and things like that. So when I transferred to NASA in 2000, working human space flight at the Johnson Space Center, and then later to headquarters, and then to the Science Mission Directorate. The same approach holds true. You need, what are the driving forces? And so when I was in the Science Mission Directorate, to me, it was just a dream. What was interesting was when you have a science requirement or any requirement, you still have to build it. And so it's a really tight coupling between engineering and science. The part that I enjoyed was with an engineering and program management background, I could look at all the disciplines without a bias, meaning I wasn't trained in one specific area. So it was either a real or perceived bias that I didn't have. Working close with the engineers and scientists, I mentioned James Webb Telescope. The backplanes had to be engineered. And so working with a scientist to say, if I have this stability, can I meet your science requirements? So it was a hand in hand the whole way, looking across the different divisions and making sure that the science, that they were all cared for, so to speak.
Mm-hmm.
I remember a discussion one time, Dr. Freilich, may he rest in peace, was a very outspoken scientist, and he was the Earth Science Division Director. And I remember him coming into my office one day, and again, he was very passionate. And we were talking. He goes, Jeff, we need to do it this way. And I'd sit back a little bit. Now, remember, I had a philosophy that said, I'm not smart, you're not smart, but collectively we're brilliant. And so we talked a bit, and I asked him a question. I said, Mike, what is the most important thing to you? Is it the science or that you get the credit for the science? And I think that's an important question because sometimes we kind of get wrapped around, I want the credit. It's all taxpayer money. Mike looked at me and says, Jeff, I want the science. I don't need the credit. And from that comment, we sat down and drafted a strategy and said, Mike, if we would have gone with what you said, we'd be fighting this thing for months and months.
Yeah.
The strategy we developed, and I won't get into that, is I told Mike, sit back, let me do something for about 3 days. If you aren't after the credit, we'll make it work. And I came back 2 days later and said, Mike, your plan, what you wanted for the science, we achieved 100%. We're moving forward. And we had full support the whole way up the chain, where we probably wouldn't have had we not had those type of discussions. So the engineering and science have to work hand in hand. It's this trade between the two that's extremely important.
I love the fact that you talked about he chose not to worry about the credit. I think that is so often lost, and not just in science and engineering, but in many business situations where people really feel that it was their idea and they want to make sure everybody remembers it was their idea. And it just stops things from moving.
It really does. And I will say probably more times than I don't like, someone would say, well, Jeff, you can't release this. You can't do this. This is my work. And I'd have to remind them to say, I wasn't aware that you paid for this whole thing. I thought the taxpayers paid for it. and so there's this balance. But, when somebody puts their heart and soul into it, they deserve the Nobel Prize or they deserve it. Right. But it's the taxpayers that paid for it. And we can never forget that.
Yeah. Oh, beautiful. Well, I also want to go back to something you talked about earlier about the large teams. And the very first one was how to deal with burnout, because this kind of issue that we just talked about is something that can wear on people. And it does create a sense of burnout. How can you give me some examples or something that will just put a little bit more detail on how you work with managing burnout?
Yeah, I can speak from how I managed it. It's not necessarily how everybody else would do it.
Mm-hmm.
I was a strong advocate of walking around, sitting in somebody's office, and just hearing them out, not coming in to complain. I had a philosophy of every Friday, I would sit and reflect what happened over that week. And I would, if they were in say at headquarters, I'd walk into their office with a hand note saying, I really appreciate what you've done and here's why. Yeah. If not, if it was a center, it would be an email, but explain, I saw this, I appreciate this. I spent time at the centers or at the contractors just to try to help motivate. Say, look, you're going through this tough. Work with me. Help me, help me lead this through this. And sometimes people just burn out. It just wears on them.
It just
But I
wears.
think from a management standpoint, if you aren't showing the appreciation, um, I remember this gets a little painful, but when I was a division director at the Johnson Space Center, I would push the team hard, but I would always tell them, I will not let you fail. I'm going to provide you that
Yeah,
safety net.
yeah, yeah.
And I pushed them really hard. We had an unfortunate death in our division. Actually, it was a murder, and I was already at headquarters at that point. But I called down to see how the team, which was no longer my team at that point, and I still remember calling the one guy, and he was at his home, and his wife, I don't know, she said, well, Bob, come do this or whatever. He goes, no, I'm talking to my boss. And when you build up that trust in the good times,
Yeah.
it helps then when things go tough. They
Yes.
trust you.
Yes. Yes. Oh, right on. Right on. Well, at NASA, there are so many scientific disciplines. I mean, everything from the physics of speeds and orbits and weights and determining launches and entries to the medical issues of weightlessness in space that you've talked about and the forces on the body of launch and return, from weather forecasting. I mean, it just goes on and on. How did you have, maybe I should ask the question differently. Did you ever have to play translator across them? Or or are NASA scientists used to being able to go across their disciplines?
Oh, that's a challenge. And so, and I'll just use the James Webb Telescope again, but this is applicable to any of the missions, large or small. You're always doing trade-offs. You want to push the envelope as hard as you can from a science standpoint, get the most science you can. But with the James Webb Telescope, there were 10 technologies that needed to be developed to achieve what Webb is doing today. And so if you look at one discipline says the backplane is going to, and I'm just using as an example, the backplane is going to warp, so I have to add this additional thing, whatever it is. Well, that adds weight. And now you have a mass problem of maybe I can't launch it. You have another one that says, well, I need more heaters to keep my electronics warm. Well, that means I need a bigger solar array or battery. So this trade goes on the whole way. So what we do is we have a systems engineer that's really literally looking across all these disciplines and becoming the person responsible to help arbitrate and do some of the trades to say, I can give up a little bit of this, but you're going to have to give up a little bit of this in order to save the mission. So you hit it exactly right on. It is such a challenge, and it's a balance no matter how small or how large a mission is. Larger missions, it's even a lot more complicated.
And I it all begins with language, because when I say the word weight, I have a thing in my mind, a concept in my mind of what weight is, and I bet you have likewise. But it's, if we began to compare, one of us would think of it one way, and one of us would really see it another way.
And you're right. I remember in one case where mass or the weight was an issue, and and it was a joint mission. I remember um, back in the days when I had energy, I guess. I remember jumping on an airplane, leaving Dallas late one evening, landing in Paris like 10 o'clock the next morning, freshening up a bit for a 1 o'clock meeting to try to work this stuff out, and then catching a plane on the way home again. So this by no means a vacation, but it took that face-to-face communication
Yeah.
to negotiate what we really needed to do for the sake of the mission. And no one is wrong. It's just
No, no,
it's broke.
that's
Um,
right. Yeah.
and for me, it takes the belief of you can solve in one day in a face-to-face that communication bridge. It takes months sometimes if you're just on a Teams meeting or a telecon or stuff like that.
Mhm.
The one thing other than I mentioned from a science mission directorate that not being a scientist, um, a thing that Dr. Ed Weiler, who was the associate administrator during one of the times when I was at NASA, kept pointing out that there's a decadal survey. And the decadal survey is something that the Congress mandates the National Academy of Sciences conduct, every decade, and they put out what's the priority recommendation back to NASA. What are the technologies we should be working on in the future? And that became the need, or they were the driving function. So for me as an engineer and a program manager, I already had that upper level need from the national academies, which is what represented the community. And so
Mm.
staying true to that was a big discipline of mine, is to make sure we didn't really deviate from that. Or if we did, there were methods where we could reconvene a group from the academies and I would say, well, we need to make one change. I did that in one case where something wasn't quite right. We reconvened and said, this is where I want to head. And they go, yeah, it makes sense, and fully endorsed it.
Yeah.
But it was that discipline that I hope doesn't get lost in all this shuffling.
Well, I want us to maybe step up a little bit to a little slightly higher elevation and look at this very broadly, because you were talking about the priorities at what I would consider to be the detail level. But how do you set big priorities within NASA? I mean, this is huge. What are things that you looked at?
Well, again, so if we step up just at the high level from a science standpoint, we do follow the academies. And that's just at the high level. They didn't get into detailed how do you design it specifically.
What do you refer to the academies? Tell me what that means.
So the national academies would put together a team of independent scientists, engineers, program managers, things like that. They would collect all kinds of ideas and concepts from the communities, and this could be national and international communities. And then they would work a process to prioritize them and say, this is our number one priority. This is our number two priority. And you need to have a certain amount of small missions and large missions and things like that, assuming the funding was there. And so an example was James Webb Telescope. That was the number one priority in 2000. In 2010, for the decadal survey, the academies said, okay, James Webb is still number one priority, but here's now the number one priority once you launch James Webb, and it's looking at dark energy. That mission, by the way, if it's not canceled, gets launched within 2 years. It's called the Roman Telescope. And so you have this where you have the backing of the community, the science community in this case.
Gotcha.
To me, it's just I like how it's going. The one thing that was interesting is if you have a mission, say it can meet all of its science objectives in 2 years. I've always said we don't know how to design a 2-year mission. Our stuff lasts a lot longer. Well, what happens if it lasts 10 years?
Yeah.
But it met everything that it was agreed to it would meet. So we would go through this thing called a senior review, where a group of independent scientists would say, yeah, this mission is still good. The principal investigator would say, now, if you let me go another 2 years, I can do this science or this science, or we're going to cancel it. And so when we look at the priorities we had back there, I don't know what happened when I was reviewing or looking at some of the missions on the canceling block now, and I suspect that methodical process has not happened. And so when you have one mission building on another and another and another, are we going to now have a gap that says we're going to lose continuity, whether it's continuity of science, continuity of technologies? Because we have, some missions, a secondary piece of the mission is new technologies to validate. It wasn't quite mature enough to have its own mission, but it would be a second string or backup. And I worry that we may lose some of those gaps. But again, not being inside NASA at this point, just from what I could read or talking to folks, I worry that step is missed and it's just cut.
Yeah. Well, I'm going to shift gears a little because I read your book called, whoops, I got to get that in the screen, Under the Midnight Sky. It was so much fun to read, Jeff, because I grew up on a farm too. And I was a middle child too. But I'll tell you what really struck me when you described how your inquisitiveness expressed itself. like getting what was it, a motorcycle and souping it up. And I thought, I was very curious. I would never have gone to try to get a motorcycle. It was just a perfect example of how a little boy looks at the world and how a little girl looks at the world. It was amazing. I just loved it.
And in that, one of the things that I'd done, and you've seen in the book, is I would on some of the model rockets that I would launch, I would view the instructions as manufacturer's opinion, not requirements, and I would put bigger motors in and things like that. And that really, in real life, NASA, there were margins for a reason. My rockets could blow up, but you certainly don't want to do that from a NASA mission. So I learned a lot about margins. I even accidentally lit my brother on fire for being careless. So yeah, a lot of imagination, a lot of interesting things growing up.
And all I did was expand the gardens.
You mentioned the book, though. One of the reasons I wrote it, because I did very poor in high school. In fact, I got a D- in English, and somebody commented, from a D- to an author. Who would have thought? But I would go into school, and I was also one that was told I wouldn't amount to anything. So when I would go into schools talking to kids, students, at the end I would say, "Was there anybody who thinks you can't achieve what I did?" And they'd all raise their hand. Yeah, I can do it. And I said, "Well, who can't?" And it's still just so clear in my mind. This young girl raised her hand and said, "I can't." So one, I give her credit for being courageous.
Yeah.
And she goes, "I just don't think I'm smart enough." And that just broke my heart. So
yeah,
as I would talk to schools, they advised me. They said, "Look, it's good you're talking, but could you write a book on your experience that maybe have better expansion to give kids hope?" And that was why I wrote the book.
Fabulous. Because I think a young person reading it I think they would get that hope. I really do think so.
What I found within that also is, it's because I've gotten a lot of comments from young kids, but from grandparents also.
Yes. Now, what do you think a young person should do themselves? I mean, okay, they can read your book to find out about themselves. I mean, I coach young people, and I love coaching young people, and I have ways to do it. But I'm curious as to what you would advise. So,
it's really tough. For me growing up on the farm, my parents really didn't give me much guidance or anything, so I experimented on my own. Leland Melvin, in his book Chasing Space, talks about when he was a child, his mother gave him a chemistry kit, and he was on the living room floor and mixed up some stuff that probably shouldn't have been mixed and burnt a hole in the floor. And his mother looked at that and said, "Chemistry, yeah," and really encouraged him. I guess the best advice I give is, don't just focus in on one thing. Try different things, and something will likely click on you that you want to follow.
Yeah.
It may not be your end goal or your end item, but it's something to at least excite the passion.
I'm really happy to hear you say that, because they really do have to try different things. After all, otherwise they won't know the experience of it. I know oftentimes students will come to me and they'll be concerned that they haven't decided on a major. What they're in college, and I say, listen, at least for a year, give yourself grace that you're going to try different things so that you can see what really resonates.
You mentioned Renee Wynn as somebody that was one of your guests.
Mm-hmm.
I had the pleasure of teaching aerospace engineering to junior and senior high school students. It was right after COVID was ending. The teacher had decided to quit and go somewhere else. I was asked if I could step in, and I decided to have various guest speakers to try to give them experience. But Renee would talk about cybersecurity, and Dr. Grunsfield about what it's like in space, and others. But it was at the end of the course, one of the seniors came to me and says, "Jeff, I was going to go into computer science or something." Goes, "But from what Renee said, I'm switching my major to cybersecurity."
Wow.
And just so it's up to us, I think, to help encourage the students,
Mm-hmm.
help provide them, hey, maybe there's another way to look at things.
Mm-hmm.
But it's those simple things.
I think that's brilliant. You're absolutely right. And yeah, they've got to talk, they've got to hear the stories from different kinds of people. Yeah. In fact, I did that for one of the students that I was coaching. She was curious about, in that particular case, she was curious about international law. So I found an international lawyer who was willing to sit and talk with her. And all of a sudden she could see, she understood much better what was involved. So yeah, we need to be telling those stories.
We do, and two of the students that were in my senior class were females, and they shared their feeling kind of awkward or whatever. And when Renee shared her experience, also, um, I then offered to set up mentors with people that I really trusted
Yeah.
that could help them. And one of them took me up on that offer. So I made the connection, and she and the other person would talk back and forth. It's as us as adults, it's looking at what they may not really believe in themselves,
Yeah.
and helping them. I mentioned technologies or space and areas like that. One of the things, I am on a board of advisors for a group called the Charles F. Bolden Group and InterAstro, where it's about the business of space more than just, oh, we're going to launch a person, but how does that reflect back on Earth? An element of that is also, how do we train and talk and excite and educate students?
Mm,
And so that's one of the arms that I bring to the group also, is
good.
just the passion to help the kids.
Passion to help the kids. That's right, because they really are the future.
They are. I remember doing a commencement speech at one of the schools, and I looked them straight in the eye and says, "Look, I really hope you get this biomedicine, remote medicine stuff down, because I'm going to need it pretty soon."
I love it. Well, I can't believe it, but we have actually run overtime. I almost never let that happen, but there's been so much to share. I really enjoyed this conversation. Uh, Before we move on, is there something else that we haven't considered that you think is really critical and we must?
No, I think we've covered the key points. If I went into anything more, deeper, it's another 2-hour discussion. So I think we've covered.
Well, then, Jeff Yoder, thank you so much.
This was my pleasure. Thank you.
You're
Every now and then, there is something that changes how I think about the world. Grounds for Thought is a place where I talk about these moments so that you can explore the meaning for yourself.
I really enjoyed thinking of Yoder standing between scientists and engineers. I felt I wanted to stand between science and engineering a bit myself, like with one foot in science and one in engineering, just to feel what it must be like. But let me explain more. Carl Sagan, an amazing, brilliant man, since passed, said, "Science is a way of thinking much more than it is a body of knowledge." I remember when my advisor told me why science always talks about being objective. Early scientific exploration was of the stars, and the stars being so distant can't possibly be disturbed by anything we might do. So, therefore, our scientific study of them would never change their course. And so, when people talk about science being objective, it means that when we observe and take measurements, we do not disturb whatever we are observing or measuring. Science is objective. But a funny thing happened around the 1970s when scientists insisted that observing a system that actually changes that system is still research that is scientific in nature, even when the observation changed the system. There was great and real resistance to this idea. But about the same time, chaos theory began to show that even in the physical universe, things could be changed by measurement alone. I recall those arguments, and I still enjoy how those in power realized that their lives had been turned upside down. Just as Sagan has said, the responsibility of science is never to suppress knowledge, no matter how awkward that knowledge is, no matter how it may bother those in power. So, this is how it means to stand on the side of science, constantly seeking truth regardless of where it leads. The other side is engineering. And Albert Einstein said scientists study the world as it is, engineers create the world that never has been. Standing on my other foot, on the other side of a very practical reality, means that when I put a screw into a hole, it must be the right size. It means that when I construct a dress, the pieces must shape themselves into something that conforms to the body. It means that when I am designing an instrument to be used in space, it has to fit in the diameter of the rocket. The scientist must theorize and measure to seek the truth. The engineer must design and construct until it performs the intended function. Scientists can theorize, but engineers must make it work. It's a space where you must be willing and able to think of two opposing ideas at the same time and not become overwhelmed. With all of his scientific prowess, Sagan honored engineering. If I understand what I'm reading about all his projects that he worked with at NASA, from the Viking spacecraft to the gold-plated plaque that contained the first physical message sent into space, the most elaborate being the Voyager Golden Record. As a scientist, he still helped create something that had never been. We live in a physical world. Knowing about this world on which we live, including this body in which we reside, still contains infinities. The mindset that explores this knowledge without suppression is what supports the engineer who can then architect progress through new invention. Stretching this metaphor a bit, if managers, like the scientists, define a goal for the company, the staff, like the engineers, have to design the actions to achieve it that fit in the resource frame. The goal may fit the vision, but it may not fit the resource frame. Standing between means holding to opposing ideas at the same time. There has to be a time to sit in the different perspectives to find a solution without becoming overwhelmed. In my own research, I found that this skill of standing between two ideas that appear to be in opposition is an essential skill for a leader. The more I learn about the brain, the more I believe developing this skill depends on forcing yourself to think about holding two ideas for a while, such as, what it means that light is both a particle and a wave. Think about that. Then perhaps doing it again with something else, another pairing, such as we often say, less is more. How can that be? Over time, it does become easier if you practice it. And the next time you meet a bridge person who can do this in their sleep, please give them a little honor. It takes energy to bridge across two ideas, two disciplines, two perspectives, because new worlds are created when you can do so. Your task now is to ponder something else from Sagan. He says, at the heart of science is an essential balance between two seemingly contradictory attitudes, the openness to the new and the skepticism toward the claims. Have fun and let me know what you think. I want to thank you for joining me today. I hope you have enjoyed the conversation and learned something new. And do let me know how you managed the balance between openness of the new and the skepticism toward claims. And if you're on YouTube, click the like button, please, and subscribe. It's a free way to indicate that you find what I do valuable. Thanks. I'm Madeline Blair, wishing you infinite possibilities as you unlock your resilient leader.